exams is on May the 9th. So here's a maths question for you. How many more days till maths exam, and are you ready for maths exam? Leave your answer in the comments. Alright, so there's about a 50% chance that the last question in your exam could ask you to solve a simultaneous equation using matrices. Here's what you're going to do if they ask you that. Now keep in mind, to solve simultaneous equation using matrices, you need to know how to find the inverse of a matrix. If you don't know how to do that, head and check out a video that I did on that already. So I'm presuming that you know how to find the inverse matrix, right? Alright, so in this question they ask us to write the equations, and they give us some equations here that they are written in algebraic form. You are asked to write them in the matrix form, right? So you need to do a little bit of textbook revision on this, because I'll be kind of speeding and just covering some key areas I think I could help people with. These numbers here, we're going to rip them out and make a coefficient matrix, which will be a 2 by 2 matrix. Coefficient because they are numbers in front of the letters. So since they are numbers in front of the letters, we'll call them coefficient. We'll use a x and y matrix, and then that's the variable matrix, and then we'll use these numbers out here. So let's see how we're going to do that, because the first part of the question is asking us to put the equations in the matrix form, and that's the step. First we put it in the matrix form, then we reshuffle it, we'll get the inverse, then we solve. It's a very simple thing once you catch the hang of it. So this is how it should look. You can see the pattern where all these numbers came from. You can see how it makes back the equation, because if this goes into that, this goes into that, it's going to be equal to this. So it makes back the equation. Matrices, powerful stuff, man. Powerful stuff, I'm telling you. So just by doing this, most of the times, a lot of the times I see in the past paper, just by writing down this, taking this, and sending it to this form, you get 2 marks. And they are giving you 2 marks right now for it. So that's a quick 2 marks. 3 marks, man. 3 marks. Alright, let's go on to actually solving it. So let me write back the equation. So how do we actually solve this? Let me just do a quick little explanation for those who are brand new to this. You have a matrix, M. You have the x and y. That's what we want to get. This is equal to some numbers here, whatever they are. And to get x and y, you want to bring across this M, this matrix, across the equal sign. So what happens to it is that it turns into the inverse, because you can think of the equal sign as anything that goes across changes into the inverse. If I'm adding 3 and it comes across, it changes to negative 3. If I'm dividing by 3 and it comes across, it turns to multiply by 3. Anything, once it comes across the equal sign, inverse. Or another way to think of it, I just want to spend a little more time on this. Another way to think of it, if I'm multiplying by m inverse here, by m, this cancels off. The inverse by the actual matrix, m inverse by m is equal to the identity matrix, which is like 1. That's like 1 in matrix language. I should also state this, that when the matrix comes across m inverse, this matrix is going to multiply by whatever was here. And so that's a 2 by 2 matrix being multiplied by a 2 by 1 matrix. Alright, this may seem a little chaotic now. Let's try and put some order into this. So it's the same for matrices. So if I have a matrix AX equal B, then X is equal to A inverse of B. So you need to find the inverse of the coefficient matrix every time. It's going to be the same thing every time. That matrix, you'll need to find the inverse. And here it is. Most of the times in the part before any question, you'd have already found the inverse. Didn't in this question though, but most of the times when you're going to your past papers, most of the questions, they'll let you find the inverse first, then they'll ask you to do some kind of simultaneous equation shindig. Alright, so let me stop talking and actually do the question. XY, so you know we need to find A inverse now, so I'm going to find the adjoint, I'm going to find the determinant. Let's just breeze through that. If you want to see a video on how to find the inverse of a matrix, look back at my earlier matrices video. I'm so proud of them. They were so well done. Alright, so we find the inverse now. First we find the adjoint, we get this answer. Then we find the determinant, we get 2. Then we're going to find the inverse. 1 over the determinant by the adjoint is the inverse. So a half, because you know the determinant went underneath there. And we got that. Okay, so we have the inverse now. So now we're ready to solve. This is what's going to take place. The first thing you're going to do is write back the xy. You're going to write the matrix now, but not the matrix. You're going to write its inverse. That's the matrix we had before, the coefficient matrix. And all that's left for you to do is a simple process. Multiply this by that. And then this by that again. row by column. That's how we multiply. And you would be able to find your x value. So you have 2 by negative 1 giving you negative 2. Negative 1 by 6 giving you negative 6. And same similar pattern takes place here. The negative 5 and 2 is going to give you, the negative 5 and 2 by the 1 is going to give you negative 5 and 2. And the 3 and the 2 by the 6 is going to give you 9. Add up those two together, and all of a sudden, it's going to break down into x is equal to negative 8 and y is equal. So I'm not beating up about the specific stuff in this video. I want you to get the concept behind it, that simultaneous equations can be solved using matrices, and how you actually do it. You bring across the matrix, you want to show that it turns it into its inverse every time. You can include the identity matrix on the left hand side to show that that cancels off as well. And you'll get your answer in the end. Try out a question on it. Here's a question right there for you. Focus especially on this part. This part has a little trick in it involved. You need to understand what the identity matrix is. Identity matrix looks like this, by the way. That's not I, and that's a 0. So that's a 0. I think I make it worse. Anyhow, so yeah. So focus on these two parts and try and solve that question using what you just learned in simultaneous equation solving via the matrix method. Until next time.